Good evening everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on electrical potential energy U. So we are being given a 2-point charge system Q1, Q2 separated by a distance R. The first question we need to find is electrical potential energy of the system. So the electrical potential energy of the system is U is equals to U naught plus K Q1, Q2 by R, where K is 1 by 4 pi epsilon naught. So if we consider U naught as 0, then potential energy will be K Q1 Q2 by R. Now there are certain graphical based question on this. So the first is graph of U versus Q1. So as we can see from the expression over here that U is proportional to Q1. So that graph will be a straight line. Then we can also see that U is proportional to Q2. So then it will also be a straight line. Here one thing is there, then whenever we draw a graph, except for the two variables which are shown on the x and y axis, rest of everything is assumed to be constant. So this is the basic assumption to be followed when we draw a graph. Then we have the graph of potential energy versus R. So we can see over there that U is proportional to 1 by R. So there are two possibilities. The first is if Q1 Q2 is positive, that means both charges have same nature, either both are positive, either both are negative. So in that case Q1 Q2 will be 0, so U here will be positive, so that will be drawn in the first quadrant and shape will be a rectangular hyperbola. Then the next question we have, if Q1 Q2 is negative, then we have the graph in the fourth quadrant and shape will still be a rectangular hyperbola. So then we have two questions. The first is if Q1 Q2 is positive, we need to find potential energy of the system is maximum when. So as we can analyze from the graph, the potential energy is maximum when R tends to 0. Next question is potential energy of the system is minimum. So as we can see from over here, potential energy is minimum as R tends to infinity. That's why if you keep the two charges like this, they will try to go to infinity, because every system wants to achieve a state of minimum energy or the stable equilibrium position. Then is potential energy of the system is minimum at, so we can see that it's minimum at infinity, as seen over the graph over here. Then there is a system of three charges placed on the vertices of an equilateral triangle. We need to find the electrical potential energy of the system, assuming that U infinity is 0. So out of these three, there will be three pairs, and each pair contributes energy kq square by L. So the total will be thrice of kq square by L. Then we have a certain graphical analysis of this. So if we analyze the relation between U and Q, so here U is proportional to Q square, that means graph will be a parabola as shown over here. Similarly, if we draw the graph between U and L, we can see that U is proportional to 1 by L, so graph still will be a rectangular hyperbola. Now there is another question that if side of the triangle is to be made n times, find work done by the electric field. So work done by the electric field is U initial minus U final. Initial potential energy will be 3 kq square by L, final will be 3 kq square by n into L. So you can take 3 kq square by L common over here, and we will have 1 minus 1 by n. So that is what is the work done by the electric field. Next we have work done by the external force for very slow movement. So we know that if there is a very slow movement, net work done will be 0. So work done electric plus work done external will be 0. So work done external will be negative of the work done by electric field. So external work will be negative of this. So that will introduce minus Ui plus Uf, or Uf minus Ui. After simplification we get this thing 3 kq square by L into 1 by n minus 1. Next is find total work done on the system. So we have brought system very slowly. That means total work done is equal to the change in kinetic energy of the system. And since system is brought very slowly, so velocity is 0. That means there will be no change in kinetic energy, and hence work done over here will be 0. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.